There we are. And we're back. We're back live. What a few days it has been. This has felt like the longest week ever. I don't know. Being in this empty classroom, I don't know. I don't know where my mind has been. It's been crazy. Yesterday, while you guys had the day off, teachers had to come into the building for a professional development for some reason on a federal holiday. And we pretty much sat in our classrooms on our Chromebooks because we needed to be in a Google Meet with a bunch of other teachers. And it just felt like, I don't know what it felt like. It just felt weird. I didn't move much yesterday. Glad to actually be standing up more. Anyway, there's 2 people in the chat when before it was like 7. That's weird and odd. Let me fill you guys in as people are filtering in. Let me fill you guys in on what's going to go on this week and next week, and more specifically, what's going to be happening with midterms and whatnot. Now, number 1, I have you this week, Tuesday and Thursday. I'm going to be reviewing said midterm with you. Review PDF is going to be posted in the Google Classroom stream in the next few minutes. I have a PDF for you, the PDF that I will be working off of. I think that considering that we are all virtual, I think it would be easiest and best if I just went through them a problem at a time. And then, of course, if you had any questions along the way, you can throw those into the chat. I'll have my phone available to look at the chat to be able to see your questions. We're not going to finish the PDF today. That is what Thursday is for. We have 2 full class, we have 2 class periods to review what we need to review in preparation for midterms. Now, in regards to your midterm will take place on January 27th. That is a Wednesday. January 27th. That is 8 days away. That is the 3A, 4A. The way that the midterms are going to work, Monday, Tuesday, Wednesday, Thursday, they're going to do 1A, 2A, 1B, 2B, and then 3A, 4A, which 3A would be you guys, of course. So that'd be Wednesday, the 27th. Now, it's going to be on Linkit, yes, and supposedly you guys will be back next week. I say supposedly only because that is what the plan is. The plan is for all of you guys to return to my classroom. Well, except for the virtual students, but to return to my classroom to take said midterm. For those who would be virtual, of course, you would be taking it at the same time virtually. We would utilize the Google Meet in order to do that, since I'm not going to be recording an hour's worth of nothing. But we'll get that thing done. Now, I say supposedly because the numbers in New Jersey are getting worse and worse, believe it or not. The last Cali report that came out from the state had our region, the Central East region in New Jersey, actually having the highest case rate and the highest CLI, the COVID-like illness rate, of any other region in the state of New Jersey. Whatever that means. Things have not gotten better. But remain to be seen. My son actually went back to school today. He goes to school on the island. He's been virtual for 2 weeks, but he actually went back to school today. Okay. Reminder for you all. No one stays home. I know. No one does stay home. Reminder for you all. I had posted a Edgelastic link for you all. I had posted it on Friday. Let me see who's got it done so far. A few people did actually get that thing done already. But it is in regards to the information that we've been doing in Chapter 6. That is due tomorrow. Tomorrow at 2 p.m., according according to my records here. I'm just going into the link right now to see who's done it. Looks like a few people have got it going. I can see that. But you got to make sure you jump on that. Make sure you get that thing done if you haven't already. So I'm going to post the PDF of the midterm review to you guys in a few moments. And while I am doing that, I am going to ask that these wonderful 14 people that I see in the chat, if you haven't already done so, please make sure you're leaving me a comment in the live chat so that I can have that for my records. That would be wonderful. You leave a comment, and I am going to post the midterm review for you guys in the Google stream. Let's just see where this takes me. Click and to post. There we go. So after you leave a comment, go to your Google Classroom stream and open up that PDF that I just posted. That would be great. I'm just looking at all the comments. No comments of, oh, Mr. Markey, we've missed you so much, blah, 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 blah. Anyway, I'm going to open up the stream on my phone so that I can follow along with whatever questions that you guys have as we're moving forward with this. Make sure I got the right link open. Come on, link open. As it's still loading. And what I'm going to do is I'm actually going to flip my camera over. There we go. So that you can see what I'm writing when I'm writing. And at certain points, I am going to... Sorry, I just saw Madison's comment. I am going to be switching to my calculator at various points. But again, the PDF that I have on display, you have available to you in the Google Classroom stream. So if you want to follow along there, that would be fantastic. Otherwise, oh, Mr. Markey, what should we write down? Well, this is a review. It's up to you. This is a review. This review is to help you study and get ready for the midterm. So my suggestion to you would be to write down what you feel might be important to remember. Something, write down some things that it's like, oh, wow, I need a little help with that or something along those lines. That would be fantastic. Certain reminders that I throw at you, or even just writing down the answers to the questions. Anything and everything would be potentially helpful in preparing for this midterm examination. So I'm looking at number 1. Now, again, if you can't see it on the board, the PDF is available to you in the Google Classroom stream. Number 1, your teacher told you to write the equation of a parabola that has a vertex of -2, 3, and contains the point 0, -1, and opens up. You are having trouble with this problem. Explain why. How would you change the problem? And then make the change you suggested in Part B to complete the problem. Now, the problem that you are having comes down to where all these things are and the description that they're giving. So to exemplify that, I'm going to build a little XY plane right here. And I'm going to put the point -2, 3 right there. That, according to the description of the problem, is my vertex. That should be my vertex. Remember, the vertex of a parabola is the either the highest point or the lowest point, depending on if it's opening up or down. But the problem also says that it should contain the point 0, -1, which is right down here. Now, there's a problem if you consider the fact that the teacher wants the parabola to open up. See, because if this is the vertex right here, if this is the vertex that I'm pointing to, and the parabola opens up from there, then the parabola should have this kind of shape that my pen tip is making. There's no conceivable way that 0, -1 could also be a point on the graph. So you're having trouble with this problem. Explain why. Well, since it opens up and -2, 3 is the vertex, -2, 3 has to be the minimum point. But 0, -1 exists lower than it. It's not possible. How would you change the problem? Well, there are a number of ways you could change the problem. A number of different ways. You could take the vertex and move it to another location in order to make it the minimum. You could take that 0, -1 and instead change it to some other point that's higher than that vertex. Or the easiest, in my opinion, is just to say that it opens down. If you change opening up to opening down, then everything else can remain the same. It's just the easiest way of going about it. Then it says to make the change you suggested in part B and complete the problem. Okay. In order to make that change, I am going to get some paper. Because if I'm going to write this thing out, I think that it would be easiest for me if I did it with a little more room, if you know what I'm saying. So that's what I'm going to do. Zoom out, zoom out, zoom out. There we go. So let's make the change and see if we can't do this. They want it to have a vertex of -2, 3. It has to go through the point 0, -1. And we made the change for it to open down. We made that change. So let's see if we can't do this. I'm going to remind you of the form of a quadratic that we used much, much earlier in this school year. I'm talking like, I want to get the glare out of that way. Hold on, let me move the glare over here. That might be a little bit easier to see now. Hold on, come on you. Might be a little easier to see. Come on, paper. I just wanted to move. Anyway, we saw this equation much earlier in the school year, probably like September, October, or something along those lines. Y equals a parentheses x minus h parentheses squared plus k. Once again, and this is like the third time, maybe, that h and k have reared its head. H and k. H, k represent the vertex. Similar to that of the square root function, where h and k represented the starting point, something along those lines. You could have also seen this in Algebra 1 when you did an absolute value function, which again, h and k made its way into those problems. H represents the horizontal shift, k represents the vertical shift. A is the same A that it's always been. It determines whether the function opens up or down. Now, what I'm going to do is I'm going to change this equation ever so gently. I'll leave that blank for a moment and do a little +3 action right there. That +3 represents the k value of the vertex. That +3 represents the vertical shift. I'm going to put the square up here. There we go. Now, the reason why I left the blank in the middle temporarily is because it's supposed to be x minus h or x minus -2 for this example. X minus -2. Because again, with your vertex right here, you could label your vertex h and k. Now, if I'm going to write in x minus -2, I think what would be best for me is if I just kind of thought about it for a second. Oh, minus a negative. Should be something like that. Now, for it to go through the point -1, opening down, there are a few things that I could try. I could guess. I could totally guess as to what the a value would be. Clearly, the a value has to be negative. But I don't know if it's like a -1 or a -2 or a -1/2. I don't know what it is. So in order to determine what that A value actually is, I am going to take the point 0, negative 1 and plug it in for x and y. Because if I plugged in 0, negative 1, and then solved that problem, it would allow me to get the A by itself. Thus, I can finally write the equation. Following some basic order of operations, I'm going to perform what's inside the parentheses first. I'm also going to subtract that 3. I'm going to subtract the 3 just because I want to. So I get negative 4 equals 4a. I think at this point it's pretty obvious that a should be negative 1. And again, you could have guessed at that. You could have totally guessed at that. The fact that it had to open down, I mean, you could have been like, oh, negative 1, and then moved on. But you just want to be careful. Could be negative 1, it could be negative 2, could be some other negative number. If you just do the plugging in and solve for the proper variable, it'll spit out the answer for you. Ultimately, the final answer to this problem is what I have written at the bottom of the screen. Let me just recap that real quick. Number 1, your teacher told you to write an equation of parabola that has this vertex and goes through this point, and the problem says open up, which we described why that was an issue. There was no way that that could happen if you actually sketched out what it was supposed to look like. So it says to make a change. So we made the change by saying it has to open down. Easiest way to go about it. I mean, you could change the vertex or you could change the point, but the easiest way is just to say, oh, opens down, and it fixes it all. That is the equation that we need. That is the vertex form of a quadratic. I plugged in the h and k where they were supposed to go. It was supposed to be x minus negative 2 and then plus 3. I plugged in the point here and here that they gave me in order to figure out what that a value is, although you could have figured out what the a value is just by pure guess and check. Oh, it has to be negative. Let me try negative 1. Oh, it works. And then by solving for a, you eventually do prove that it is negative 1. And then you get that equation at the bottom, which is just oh so nice. All right. Let's flip back to number 2. Again, we're not going to get through everything today, but that is what today and Thursday are for. Number 2. A box has the following dimensions. It says to write a function for the volume of the box. Ugh. It's heartbreaking. Oh, wait. Volume of a box. Length times width times height. Okay. Length times width times height. Let me get a piece of paper here. Let me write down some of this junk. Length times width times height. For this box, it looks like they want me to perform the following calculation. When they say to write a function for the volume of the box, it looks like I'm going to write it out to look like that. I think that would be my best bet. In order to multiply these out correctly, again, this is going back to September, October. If I'm going to multiply out polynomials like this, sometimes it's best to take them a piece at a time. Notice I'm just taking the first 2 and multiplying them together. X squared, 3x, negative 2x, negative 6. This will give the result of just multiplying the first two parentheses together. This gives me x squared plus x minus 6. Some people still prefer FOIL, and that's fine. You can totally still use FOIL here. You can. That's acceptable. But for this additional multiplication that you have going on here, unfortunately, FOIL is not going to work the way you want it to. You could do some level of distribution if you wanted to. Again, completely up to you. As for me, I'm going to use another box. But this time, I am going to use a larger box that looks like this. Put an x, -4 here, an x squared, an x, and a -6 here. Going to multiply that junk out. In my opinion, this is the absolute easiest way to visualize the problem. Remember your exponent properties as you are multiplying within this box. And then you simply have to combine like terms. Inside that box, the like terms would end up being x cubed minus 3x squared. I'll talk about that in a moment. Minus 10x plus 24. That would be the formula or the equation that they're looking for part A. Number 2, part A. The reason why that worked out like that with the -3x squared, there was a 1x squared here and a -4x squared here. This is just combining like terms. To be like terms, if you're adding or subtracting like terms, you have to have the same variable, the same letters, base, whatever, and the same exponent. -6x, -4x make -10x, etc. But then for number 2, it says to use a graphing calculator to graph the function. All right. Now it says for -10x, -10, or +10, whatever, ignore that. That's just telling you the size of the window. That's just telling you what your x-axis should look like. What I'm going to do is I'm going to go to my graphing calculator. Now you could go to your graphing calculator. You could also go to Desmos for this if you wanted to. Let's take a look. Calculator. Let me reset this. Okay. So x, that's not an x. X to the third power minus 3x squared minus 10x plus 24. Again, you could use Desmos for this as well. I mean, obviously, if they wanted you to provide visual representation of this, you could do a screenshot if you wanted to, and then just kind of paste that screenshot where it needs to be. But let's graph it and see what happens. Oh, gross. That is gross. You can't even see all of it. Ugh. See, that's the unfortunate thing with the graphing calculator. It doesn't give you the whole story. It doesn't give you the whole story. They say use a graphing calculator to do this, but the window is off. In fact, it would be beneficial to us if this window were moved up a bit, but you can't, like on Desmos, you can click and drag and zoom in and out. Zooming won't help you here. And actually, you have to change the size of the window. I'll do it on Desmos in a minute to make it a lot easier. I'm going to change the Y maximum to 20. Still not enough. I'm going to change the Y maximum to 30. Much better. If you want to change the maximum values on the axis, if you click window, you can actually manually change them. I didn't change anything else. Don't change anything else. All I did was change the Y maximum, and that made me feel a lot better. Graph, and you can see it there. Then it says to look back on your graph and identify local max and mins. Again, this would be a lot easier on Desmos. Trace. I don't know. It's about there, I guess. Like -130 or some chunk like that. -1. Can I see? Nope. That's a syntax error. Change that to that. Ugh. Yeah, -130, I guess. And then like 3 -6. It says, local max and mins. It's basically, what are your turning points? Estimate what your turning points would be. See, again, if you use Desmos like a smart person, if you went to Desmos, as I've shown you to use in the past, you could easily type in your function like this. X to the third minus 3x squared. It's much more user-friendly here. Plus 24. Zoom out a little. Click and drag. Zoom out. There it is. Look, I found it. And look, click, click. I found your maxes and mins. It's a lot easier on Desmos. And then, of course, you could screenshot and include that. But, it's neither here nor there. You don't have to get the exact value. You just have to approximate what the value would be. The max would be -130, and the min would be, 3, -6 or something like that. That's approximate. Desmos gives you exact. Stupid calculator. Then it says, do these values represent minimum and maximum possible volumes of the box? Well, yes and no. It could represent a maximum. It could. However, it doesn't. The first ordered pair that we're kind of looking at, hold on, let me type it in actually. There it is. -130. -1, 30. Oh, it's a maximum volume. Cool. But then you'd have -1 as an x value. You can't have negative feet. You could try to plug it in. You could try to plug in -1. But you're going to get negative feet on the sides of this box. It's not going to work. For the minimum right here, you have 3 for the x value. But then you get a negative volume, and you can't have negative volume here. Let me come up to the board real quick. I want to draw something on this picture. Ow! I just hit my kneecap. The only way that you're going to get some kind of volume here is if you're dealing with values That's a fun noise. If you're dealing with values that definitely have that positive x value and that positive volume, but there's a little bit of an issue to this. I'm going to erase something on the board in a moment. This is the equation x plus 3, x minus 2, x minus 4. See, if I had an x value in this range right here, from 0 to 2, it would force this length of the box to be negative. Any number from 0 to 2 would force actually both of these to be negative. So even though that would be a positive volume, that's not going to fly. This point right here is the 0.4, 0. You can't have a box with a 0 volume, so that ordered pair won't work either. But according to the logic of the situation, anything in this range right here, anything in that range of the box, that could represent the volume of the box. Positive volume and a positive length on all sides of that box. But I digress, because we're about to do some problem solving on this sucker in a moment. The real crux of this problem comes down to part E. If the volume of the box is to be 72 cubic feet, what will the dimensions be? This problem is something that we spent an extraordinary amount of time on over the course of this school year. What I'm going to do is I'm going to write down the equation, and then I'm going to rewrite it ever so quickly. There we go. I'm going to rewrite it again. I need you to think back. I need you to think back to the things that we've done in class. I need you to think back to how in the world would we even begin to solve this problem. This problem, well, first of all, it is a higher degree polynomial. It is a cubic. They're saying that let the volume equal 72 and figure out what the dimensions will be. We need to solve this. We need to get x by itself. As always, as people in class opt to remind me, and again, since you're all virtual, I will just ask this rhetorical question and then kind of do it on my own. But if you want to begin solving this problem, if you want to begin any step whatsoever, you're going to need to get one side equal to 0. Remember, if you're solving something like this, you are trying to find the zeros of the function, the x-intercepts, the roots, the solutions. I'm going to need to get one side equal to 0. I subtract 72 from both sides. And now, lo and behold, I need to bring back a monster that has haunted you from the beginning of the school year. Probably not the beginning, maybe like end of October. Synthetic division. We need to solve this. And the best and easiest way to do it is with synthetic division. I need to take this particular equation, this one equal to 0. I need to put it into the graphing calculator, into the y equals key. And I need to visibly see, where does this cross the x-axis? Because if I can see where it crosses the x-axis, I can use synthetic division to divide that 0 out of it. Ultimately, I can find all of the zeros. I can prove all of the zeros. Let's see what happens. I'm going to go to my calculator here. Going to change this to a minus 48 because that was the big change. Let me graph it. I'll put my window back to normal. Oh, snap. It looks like it only crosses at one particular location. Positive 6. Let me prove that. The way that I'm going to prove that is with a synthetic division. And notice I put that 6 on the outside. Mr. Markey, where did that 6 come from? It came from right there. Where did it cross the x-axis? Positive 6. So I'm going to test it. Remember, in the synthetic bar, you're only putting these numbers. You are not putting the variables. And as a reminder, with synthetic division, it is a repeated process of adding and multiplying. Add to nothing, multiply against the 6. Add, multiply, add, multiply, add. That 0 in the bottom right proves that positive 6 is indeed a solution. It proves that it is a solution. Now, if I look at this resulting numbers at the bottom, the 1, the 3, and the 8, that is the resulting quadratic. I took a third-degree polynomial. I did synthetic division once with a 0 that I found. I whittled it down to a quadratic. Now remember, I'm going to point to them. Remainder, constant, x squared. The resulting equation is an x squared plus 3x plus 8. And it doesn't take that long to find out. It does not take that long to find out that this particular equation doesn't have any real solutions. Because if you were to actually attempt to find any real solutions, you would find that the discriminant, what I just wrote down, is negative. And because the discriminant is negative, there are no more real solutions. In fact, I have proven that 6 is the only real solution to this problem. Now, I'm not done with the problem, but this kind of goes a long way. Let's kind of recap what we've done so far. I'll recap and then we'll wrap up this problem. First, in number 2, they said a box has the following dimensions. Write the function. Okay. I'm going to multiply them together. I'm going to multiply them together. I'm going to multiply them. Oh, there it is. I found it. Cool. Then it says to use a graphing calculator to graph that sucker, which we did. We had to change the size of the window. It's a lot easier to use Desmos. Then it says to look back at your graph and identify any local max and mins. That's just a visual like, hey, where are the turning points? The turning points are your local max and mins. Do these values represent possible volumes of the box? Turns out no. One of them was negative 130, and that negative 1 produced a negative side length on the box, so you can't have a negative side length. And the other minimum produced a negative volume. You can't have negative volume. Part E, if the volume of the box is to be 72 cubic feet, what will the dimensions be? Well, that's where this process comes in. Setting the equation equal to 72, setting it equal to 0, using synthetic division in order to solve it. I got that 6 by looking at the graph of this equation. But now the problem is, what are the dimensions of the box? Well, since the dimensions of the box were originally this, and since 6 is the value of x, I plug that 6 in for each of them, and I get the following dimensions. Those numbers all multiplied together do give you 72 cubic feet. But I take that 6 and I plug it in, and there it is. Okay. Let's take a look at number 3. Number 3 is going to deep dive some more quadratic stuff with us. Let's see here for a second. There we go. Number 3. A rocket follows the following path. H of t equals negative 4.9 t squared plus 49 t minus 97.5. That's weird. The variable t represents time in seconds, and h of t represents the height of the rocket in meters. To graph, use the following dimensions. All right, cool. The first question is, when will the rocket hit the ground? You don't actually have to graph it for number 3. Number 3, they said to graph, use those dimensions. I'm not actually going to graph it. Because A, B, and C don't ask me to graph it. They're asking me different questions. The first question is, when will the rocket hit the ground? When will the rocket hit the ground? Notice that when I said that, what I wrote was a 0 for the height of the rocket. If the rocket's going to hit the ground, then the height of the rocket is going to be 0 feet off the ground. So I have to solve this. Oh, I don't know if I can solve this using synthetic. Oh, I don't know if I can solve this using factoring. Oh, gosh. What do I have to use to solve this? Oh, right. That thing that haunts my dreams. Negative b plus or minus the square root of b squared minus 4ac, the whole thing, over 2 times a. This is the easiest way to solve this problem. The absolute fastest, easiest way is to just jump straight to the quadratic formula. It may not be the cleanest way, but it is the easiest way. First thing I'm going to do is I'm going to calculate the discriminant. The discriminant, the b squared minus 4 times a times c. I'm running out of room here, so let me just box this off. There we go. Be careful with your negatives. Be very careful with your negatives. I'm going to use my calculator real quick to just kind of type that out. 49 squared minus 4 times negative 4.9 times negative 97.5. I got 490 right on the dot. Okay. I don't think 490 is a perfect square. Let's just see what happens. To finish the problem, I go negative b, which is negative 49, plus or minus the square root of that 490. That's interesting. Anyway, and then it's all over 2 times a, which is 2 times negative 4.9. Sorry, I just thought it was interesting, the 490 versus the 49, but I think that's just a coincidence. In order to do this correctly, let me show you how to type this out on your graphing calculator, because typing it out on your graphing calculator can potentially be a little tricky. I'm going to type this sucker out. First thing I'm going to do, parentheses, negative 49 plus the square root of 490. Now notice that little arrow. I'm going to tab to the right and close the parenthesis. Now, I'm not done with the calculation yet, clearly, but I just wanted to point out a couple things. First, the 49 has a negative sign on it, not the minus sign. And I do plus because I can't do plus or minus at the same time. I'm going to have to redo this calculation with a minus. But then I get the 490 in that square root. Now, with your calculators, you do have to get out of that square root by tabbing to the right to get rid of the arrow key. And then I close the parenthesis because that's just the top of my fraction. So I'm going to divide. Parentheses, 2 times negative 4.9, close the parentheses. I just want to make sure that the bottom of the fraction is actually calculated separately, because I don't want to mess this up. Let's see what happens. Enter, and I get an answer. Now, is that my actual answer? I actually don't know at the moment. I'm going to need to redo that calculation, but instead of a plus square root, I'm going to have to do minus square root. A trick for you all. I've said this in class, but this is a trick on the calculator that could help you. Second, enter brings everything right back. And if you just tab over to the plus sign and type in a minus sign, you don't have to retype everything. You get a different answer. Now, I actually got two answers here. That's strange. That's very strange. I wonder what's going on with this thing. Everything we did was correct, but we did get two answers. The question is, when will the rocket hit the ground? Well, there's two ways of kind of thinking about it. And the rationale that I can come up with is this. We got two positive answers. Perhaps the rocket was under the ground originally. I'll draw you a picture, actually. This would be great. This is very strange. Hold on, let me write down these answers. We got 2.74 and 7.26. I'm just writing them down for my own sake and just double checking my numbers. This feels oddly strange to me. Why would they both be positive? I'm just double checking my equation. My equation's correct. 97.5, 97.5, 4.9. Yeah, b squared minus 4ac. You can tell I didn't write this problem. But check this out. It's like, imagine an XY plane right there. And imagine that the rocket, I'm going to draw a rocket here. It's going to be fun. No, math does make sense. It's just that the people who choose to describe it, there's my rocket. I'm going to put USA on the side. USA. There we go. I'll zoom in on my rocket. There we go. It says USA on the side. And I guess initially 2 seconds have to go by for it to launch, and then it comes back down at 7 seconds. That would be my logical thought to it. See, Madison, to answer your question, my response usually is something like this to your statement. There are two ways of thinking about mathematics. One is the way that mathematics exists in the universe. And two, the way that human beings decide to describe mathematics. No, I'm not going to say the person who wrote the problem is not smart. I'm saying that the person who wrote the problem didn't think this through properly. Because this was a review that was given to me saying, hey, review this with them. Okay, I'll review this with them. I think this problem is flawed. But the process that I just went through is correct. The process that I just went through is correct. You have all these decimals in the problem. You want to know when this thing will hit the ground? Well, that's when the height is 0. When will the height be 0? Well, I used the quadratic formula. It spit out two different answers. Yes, and both were positive numbers. Now, assigning context to those answers, I had to stretch that a little bit by talking about a rocket under the ground and stuff like that. But the process that I went through is 100% correct. The context of this rocket may not be perfect. But again, that's human beings for you. It's very strange. If you think about it, like, you guys all know the symbol for pi. You know the symbol for pi, the number 3.141592653. You know that number. But we didn't start using the symbol for pi until the 1800s, when one mathematician thought, why can't I just use a symbol to represent this concept? Because before then, whenever a mathematician wanted to cite the number 3.14159, all that other stuff, whenever they wanted to cite that number in a mathematical paper, they wrote out the full sentence of the ratio of the circumference of a circle to its diameter. They would write out that full sentence. And then when they wrote out that full sentence, then people would be like, oh, now I know what you're talking about. And then in the 1800s, the guy's like, why don't we just use a single symbol? I'll just pick a Greek letter. And they picked a Greek letter. It was great. Anyway, how high will the rocket be at 3 seconds? Well, if if we want to know how high that rocket will be at 3 seconds, it's a simple matter of plugging in 3 for t. How high will it be at 3 seconds? I don't know. Let's just find out. All right. Negative 4.93 squared plus 49t. That's not a t anymore. It's a 3. Ha ha ha. Minus 97.5. I'm going to do this calculation. Negative 4.9 times 9 is 49 times 3, 97.5. Boom. I get 5.4. This rocket, not going very high. 5.4 meters. Made in the USA. Then part C, what is the maximum height of that rocket? Well, if I want to find the maximum height of that rocket, that sounds like a vertex problem to me. A vertex, you're going to have to remember negative b over 2a. Now, by finding that calculation, you wouldn't find the height, the maximum height of the rocket. You would actually find the time that it takes for the rocket to reach that maximum height. Let's take a look. Negative 49 over 2 times negative 4.9. Again, please be careful when you're typing this into the calculator. Negative 49 divided by parentheses 2 times negative 4.9. Please be careful when you're typing this into the calculator. 5. Now, 5 represents the number of seconds it takes for the rocket to reach the highest point. That's what the vertex formula technically does. It gives you the x value, or in this case, the t value. In order to find the highest point, you're going to have to take that 5 and plug that sucker back into the equation. I'm actually going to use the previous calculation that I just did, but instead of 3, I'm going to plug in a 5. So let's see here. That times that. That times that. Boom. 25. 25 meters. That would actually be the answer to that particular question. Nice. Here's what I want to do with the time that we have remaining. I am going to not skim, but I'm going to go through what concepts that we are going to be covering in the one more class period of review that we have. Now, believe me, there's not a lot of extra stuff here. A lot of the stuff is like more recent stuff that I'm not going to spend a ton of time on. But the stuff that I have been talking about, the concepts that I've been going over in these open-endeds, apply so much to the remaining problems that we have. For example, number 4. It says for the equation, find the following. Find the value of the discriminant. Well, we've been doing that for the previous problems. We found the value of the discriminant for 2 previous problems. B squared minus 4ac. Describe the number of types of roots. We'll talk about that. Well, if it's negative, it's going to be complex. And if it's positive, it's going to be real. Find the vertex. We just went over the vertex formula. Find the exact solutions using the quad formula. We just did that as well with the previous problem. Let me take a look at the next page where they have like this multiple choice stuff. Number 1, what is the remainder if you divide those 2 things? That's synthetic division. What are the x-intercepts of this quadratic? Well, you could factor or quad formula. They want you to graph that sucker. Well, you do have a graphing calculator to kind of help you get that thing done. You do. You could put that into your y equals key, take a look at the table of values, which we're going to do that next time. What are the solutions? Well, that problem's already factored. Just take each of the factors and set them equal to 0 and solve. Where will a graph of the parabola cross the x-axis if it has zeros at 4 and -2? What kind of question is that? What kind of question is that? That's a ridiculous. Who made this review? At 4 and -2, or at x equals 4 and x equals -2, or at the point 4, 0 and -2, 0. Ridiculous. Like I said, a lot of these problems, like number 6, 7, 8, 9, 10, those are problems that we've just recently done in the most recent chapter. I'm going to focus in on those next time as well. There be a box. Oh, a small rocket is fired. Again, I really hope that problem's nice. We'll talk about that. Express the volume of the box. Multiply all those together. We did that too. Oh, yeah. We're going to rock these things. Because a lot of this is just rehashing everything that I just did today. But today I did it in a much, much, much slower fashion. So here's what I'm going to suggest to you. Between now and Thursday, take your time. You don't have to complete this review. But you should try some of the problems in preparation for Thursday. And then on Thursday, we're going to knock out all of these problems. It's going to be fantastic. Madison has a question about the test when you get the chance. When you're referring to the test, are you referring to the major that I assigned you guys that is due tomorrow, or are you referring to the midterm that we are taking next week? Okay, go for it. The major, which is on edge elastic, which is, of course, like I said, due tomorrow, is based on Chapter 6 material. I did all the work in edge elastic itself instead of on paper, and I'm not sure if you can see the work I did. Is that going to be an issue? No, it is not going to be an issue. I don't typically need to see the work on edge elastic because typically those are either multiple choice or click and drag problems, or you actually like type out your response or something like that. So no, it's not an issue whatsoever. It's not. No, don't be sorry. Don't be sorry for asking a question. Anyway, I'm going to end class now because the class is going to end in approximately a minute and a half. If you have not left a comment into the chat, please make sure that you do so. And I will see you guys on Thursday to finish reviewing for this midterm. Reminder, your midterm is on Wednesday, the 27th. Supposedly, you'll be in school, but I will believe it when I see it. All right, I'm going to sign off. Goodbye, goodbye. Take your stuff with you. Bye-bye, bye-bye. Socially distance in the hallway. Bye-bye, bye-bye, bye-bye. Get out, bye-bye. Remember that stuff under your desk. Bye-bye. Okay, bye-bye.